Hello and welcome to the chapter on permutations. So today we're going to learn about how to permutate objects. So how many different ways can I arrange these three letters? Well, if I do three random blanks, there would be three ways I can pick a letter for the first blank. Then if that one's picked, there's two letters for the next blank, and then one letter for the next blank. So there's a total of 6 ways I can flip-flop these three letters. Now, how many ways can I make a three-letter combination out of these? There's 7 letters. So now if I have 7 blanks, or 3 blanks, there's 7 ways I can pick a letter for the first one, 6 ways for the second one, and 5 for the third one. So if I multiply those together, I'll get 30 times 7, which is 210. Now this is a permutation. A permutation of a set of objects is an arrangement in a definite order of some or all of the elements in that set. So if I want to take these books, and if I want to place only 4 of them on the shelf, how many different ways can I arrange them? Well, there would be 6 ways I can pick my first book, 5 ways my second book, 4 ways my third book, and then 3 ways my fourth book. So this would be 30 times 12. 30 times 12 is 360. Now we start to get into a little trickier problems. How many ways can I rearrange the letters of SEQUOIA so that Q has to be in the 4th position and it has to end in a vowel? Now we have to talk about fixed positions and restricted positions. The first thing we need to do is label our fixed position. So our 4th position has to be a Q. So there's only one option there. Our restricted position is the last one. That's what we do next. And it looks like there's 5 different vowels that we could pick. So once we have these 2 out of the way, now let's go back to the beginning and see how many we have left. There's 7 letters, and we've already chosen 2 of them. So then there would be 5, then 4, then 3, 2, and 1. Now when I multiply all these together, I'll get all of the possible combinations that I can have a Q in the 4th letter and a vowel for the last letter. So 20 times 3 is 60, 60 times 2 is 120, 120 times 5, I believe, is 600. Alright, now how many permutations are possible if I don't have any restrictions? Well, then I could have 7, 6, 5, 4, 3, 2, 1. Alright, now in this case, we just have to multiply these out. And so 7 times 6 times 5 times 4 times 3 times 2 times 1, that's 5,040. So now, this asks what is the probability that if I rearrange those letters that I'll get a Q in the 4th position and it ends in a vowel. Well, there's 600 out of 5,040. So our probability is 600 over 5,040. Now if I divide that out, that answer will be 0.119. So about 12% of the time you'll have a Q in the 4th position and a vowel in the last position. Now if there's 24 people in a club, how many ways can we choose the president, vice president, and treasurer? Well, there would be 24 ways I can choose the president, 23 the vice president, and the treasurer would be 22. So if I do 24 times 23 times 22, my answer will become 12,144. Now let's talk about factorial. Factorial is kind of, I think some of you have seen these before, so you've been saying that probably through this whole lesson. 3 factorial is 3 times 2 times 1, which would be 6. 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 would give us 50,400. And we have to define 0 factorial to be 1. There's a few different ways we can do this, but I think the best explanation is this is how many ways we can rearrange 3 letters, and that's 6. How many ways can you rearrange 0 letters? 1. You don't arrange them at all. But any way you think about it, we need 0 factorial to equal 1. Now the Hawaiian language only has 12 letters. How many different 2-letter permutations are there if the letters must be different? So 2 letters, that would be 12 times 11, or 132. Now how many 4-letter permutations are there? So that would be 12 times 11 times 10 times 9. So 12 times 11 times, oops, that's 11,880. How many 12-letter permutations? Now this would be 12 all the way down, so we can just say 12 factorial. Now, we can write them 5p2. That means we have 2 items, and we start with 5. So there would be 5 ways times 4, so that would be 20. Now we need to think about how we can write this using factorials. Now 5 factorial would be the numerator, and we want to divide by 3 times 2 times 1 to cancel out the rest of it. So that's 3 factorial. Or if I say 10 permutate 4, that's 10 factorial over 6 factorial. Because this would be 10 times 9 times 8 times 7. And we want all the rest to cancel out, so 6 factorial has to be underneath. So the formula will just be n factorial over n minus r factorial. Now, if we have repeated elements, so if we look at the word carrier, it has 7 letters, but there are fewer than 7 factorials because some letters repeat. There are 3 r's. So we have to divide by how many ways we can move around those 3 r's, because if I change the position of these r's, it would still create the same word. So I have to divide by 3 factorial. However, if we have a word like Mississippi, where we have 4 i's, 4 s's, and 2 p's, we have to take 11 factorial divided by each of the repeated ones factorial. So try this one, Massachusetts. Take a second, pause the video, and see how many permutations you can get out of the letters of Massachusetts. Now I get 13 factorial to be the numerator. Now I want to divide by how many m's. There's only one m. Looks like there are 2 a's. S's, there are 4 s's. And 2 t's. So 13 factorial over 2 factorial times 4 factorial over 2 factorial. Now if we divide this out, we should get how many permutations there are in Massachusetts. Now this gets a little funny. How many different ways can you arrange 4 people around a circular table? If I have a table, I have 4 people, 1, 2, 3, 4. If I have 4 people I want to choose for the first position, 3, 2, 1. Now if I rotate the table 90 degrees, I'll have the same positions, but people are going to be next to each other the same way. They're just going to be in a different location. And we want different arrangements of the 4 people. So I need to divide by how many ways I can shift. So if I had 4 times 3 times 2 times 1, you can flip it around 4 times. So this would be 3 times 2, or 6. Now another way to look at this is we can have the first position called the fixed position, so 1. And then there will be 3 ways I can choose the next person, 2, and then 1. Or 3 times 2, 6 ways we can rearrange those people. Alright, here's your homework for tonight. Good luck.